Welcome to everyone who's interested in finding out a little bit more about UCloud. As you can see on the screen, this is a presentation of AI applications on UCloud with a little bit of information provided about what kind of AI hardware and what kind of AI tools are available for researchers to use. The agenda for today's presentation is going to cover a quick introduction to what UCloud is, essentially. We'll get into a little bit about the HPC landscape, and for anyone who hasn't heard that before, it's just high-performance computing. And it's a bit of a misnomer in the sense that we're not only talking about high-performance computing, but also cloud computing solutions that just make your life easier by working in the cloud. UCloud is essentially a cloud platform. And for those of you who haven't heard about it, it is a collaboration that has been orchestrated by DeiC, the Danish E-Infrastructure Corporation, and supported by a consortium, so the DeiC Interactive HPC. So interactive being high-performance computing that you get your hands on and you get to sit with and work with. And it has been provided by Aarhus University, Aalborg University, and a very big contribution by South Denmark University, or SDU, at the E-Science Center. So what is this UCloud? It is a cloud platform where you have the opportunity to have your own cloud computing space. You can personalize your workspace in the sense that you can use the applications that you want to use. You don't necessarily have to install anything on your local workspace, but you can customize your workspace to suit your workflow needs. It's very easy to access. Everything on the UCloud platform is web-based. You can access via terminal programs for some of the more advanced applications, but everything that is on the UCloud platform can be started from just a web interface. It's a great place to collaborate. You can set up projects, work with people inside your university, as well as people from outside your university in the Danish university environment. And you can work with people from outside the universities entirely if you get permission to have users created on the UCloud platform. It has ready-to-use applications. These ready-to-use applications are pre-built Docker containers, and those Docker containers allow you to start an application, run it as the latest version, and basically just point and click at whatever application it is you want to run. And you don't have to actually install anything on your local machine. Everything is cloud-based, and because it's in a Docker container, everything is also consistent and compatible. The applications are updated, but these apps are updated, and you have access to generally, if not the most up-to-date, perhaps one update back to make sure that the release that's available is stable. You can also access the older versions. So when you're in an application, there's a drop-down box, and there are a number of previous versions that are accessible if you choose to run one of the older ones. This is particularly helpful if you want to be able to reproduce research using a particular environment. Beyond that, it's just a very user-friendly interface. You'll see when we get to the presentation in a little while that it's actually quite easy to navigate and get started using what is essentially a supercomputer. And finally, you can customize your compute power. And that means that depending on the scale to which you need to compute to a large degree, you can basically get all the required compute power that you need. There are limitations, of course, and we'll get into that when we have a look at some of the providers. A major benefit of this UCloud interface is that if you're working in the SDU provider, and I'll get into what providers are in a second, there are 3 primary providers in the interactive HPC space. In that space, the SDU provider provides a possibility to use AI tools that have been added to UCloud on sensitive data. So for example, if you have sensitive interviews or if you have sensitive audio generally that you need transcribed, you can run the Transcriber app provided your data is stored in that provider's storage. Every person who wants to access this service needs to make sure that their university has a data processing agreement with SDU, and particular with the E-Science Center at SDU, to make sure that you are allowed to put your data onto the service. But you should contact your front office to get more information about that. I'll show you in a moment the DeiC front office, or at least the DeiC Interactive HPC front office contact information. And then that's it for the basic introduction to what this platform is. It doesn't tell you much about how it looks or how to use it, but those are the basics. If we then head over into an internet browser, you could browse to interactivehpc.dk. This is the current page where you can find some of the latest news, as well as contact information for both your front office and for the additional services that you might want to request or try to apply for. The front office contact details are under resources in this drop-down tab, and you can just click on front offices. And from there, you can browse down to find out what the contact details are for the front office at your university. With that, let's get on to the UCloud environment. You can browse to the platform by just searching for UCloud and SDU in the same string, and you'll find that that'll bring up the top link to the UCloud interface. If you click on that, you get taken to the DeiC, or Danish E-Infrastructure Corporation, login portal or integration portal. And if you click on that green button, the WAIF button, you'll be asked to verify your WAIF credentials or your university login credentials. And once you do that, it'll take you into your landing page in the UCloud interface. UCloud is, as I say, a collaboration between multiple universities, and the two universities that are providing compute resources to the platform at the moment are Aalborg and SDU. If you scroll down on your landing page once you log in, you'll see there's a section called Providers, and you can click on View Details to see all of the providers that are in the platform. The first one in the list is the DeiC Interactive HPC SDU, or South Denmark University. That provider is the one where you're allowed to place sensitive data on the platform. The second two providers provided by AAU are permitted only for public data or low-risk internal data. And you'll see why that's relevant, of course, if you're doing any research with sensitive data. Each of the universities has their own data classification process and scheme. You need to consult with your legal department at your university. At Aalborg University, we have a process for this where you are required to go and register your data with the Department of Grants and Contracts. We have all of that documented on our website, but for all of the other universities, you need to get in touch with your front office and just double check what it is that you need to do if you want to work with sensitive data on the platform. All right, I'm just going to go out now back to my PowerPoint presentation just to show you what the landscape looks like. If you could ignore the right-hand side of this plot over here, the right-hand side is type 2, type 3, and type 5 HPC. But what we're talking about today is this type 1 or interactive HPC on UCloud. And the SDU component, as I said, is the place where you can get access, or you are permitted to work with sensitive data. Because today's presentation is primarily focused on AI applications, I think it's very relevant from a hardware point of view to point out where you can get access to GPU resources. Because for model training and for inference, or using what many people like to use in terms of large language models, access to a GPU is often very relevant or necessary. In the Aalborg K8 provider, there are a number of NVIDIA GPUs available, and the size of the memory on these GPUs essentially goes up as the number goes up on the title, or at least on the model number. You can go and Google these models to check specifically what you need, but these the size of the memory on the GPU is important for deciding how big a large language model you can host on the GPU when you want to start asking questions, for example, to a chatbot. It's also very useful to know that if you want to do transcriptions, you're not limited to only using a GPU. You can do the transcriptions on a CPU machine. And when I do the demo in a bit, you'll see that the example that I provide is actually just using a CPU machine, because everybody can do that without applying for a project. Beyond that, the other two providers that I mentioned, the Aalborg provider on the left-hand side here is a virtual machine provider. The only applications that can run on the virtual machines are virtual machine applications. So the majority of the applications on UCloud can only run on these two down here on the right. But that's just to give you an idea of what GPUs are available. The GPU on the SDU part, the H100, is the biggest one on the platform. It has an onboard memory of 80 gigabytes, and it can comfortably handle one of the big 70 billion parameter large language models. And you'll see why that's relevant when we get to that part of the presentation. Before we go into having a look at any of the demos, we're going to quickly run through what a project is, or how you apply for additional resources on the platform, and what these resources look like. What does it mean to get resources on UCloud, and why is it relevant to you? So if we switch back to the UCloud interface, you'll notice that when you log in, you land on your My Workspace landing page. In the top right-hand corner is a drop-down, and that drop-down allows you to see what projects you've been included on the platform. It also allows you to star or favorite some of those projects to get them up to the top of your list. I have this project Transcriber and Chat UI demo that I've created, and I'll show you in a second how that project was created. Before we go and do that project creation, I just want to show you my initial resource allocation in my workspace as a Danish kroner amount. And that's because I opened this UCloud interface before the new front end was launched in May this year. But all of those who only open the interface for the first time now will receive a 2000 core hour or CPU core hour initial allocation and a 100 gigabyte storage allocation in the UCloud space. The next thing I want to show you is on the left-hand side that there is a pop-out navigation pane. In the pop-out navigation pane, the first thing down is a folder, and you may have guessed that is how you can navigate to see what files you have on the platform. If you click the Drives button at the top of the screen, you'll see that it takes you to the drives that are available inside this particular project. If I switch over to my project that I have running, you'll see that the drives update to include a folder called member files. And that member files folder is created on that provider's service when you have a successful project application and you get the allocation on your project. So I'll go back to my workspace so you can see it changes back, and everyone has this home directory that is created automatically. And it really is the same as just browsing files on your computer. You can create folders, you can rename them, you can load things into them, copy them from one place to another on UCloud, and so on and so on. The next button down is a project section where you can see all of the allocations you have inside this workspace or inside this project. The next one down is usage, which allows you to see how and when you use different parts of your allocations. The next one is your list of grant applications. And finally, you can apply for resources. If I click that Apply for Resources button, it takes me to a project application screen. Each of the universities has their own specific way in which you should apply for resources, and you should consult your front office just to double check how they would like you to do it. At Aalborg University, for example, we require that all of our users complete a form via our HPC website. But for users coming from any other university, please double check this with your front office. As a minimum, you have to provide a project title. This can be provided automatically if you don't put anything in there, but we recommend providing a project title that is appropriate for the work that you're doing, and also is going to be something that is recognizable when you need to browse it in your drop-down menu on the top right-hand corner when you switch between your projects. These projects can start from a particular month, or they can start immediately. You can select a minimum of 1 month and a maximum of 24 months for this allocation. The very first time you apply for a project And in that project, you're provided with allocations of different resources. And those allocations are going to be affected by the amount of time you specify here. The project itself will continue to exist indefinitely, but the underlying allocations are going to be modified by changing this time span. If I choose 1 month, the time span I'm going to be allocated is the month of December, which is the month I'm currently applying in. So it will be scaled back to the 1st of December, and it will end at the end of December 2024. The only grant provider we have at Aalborg University for our users is this Type 1 grant provider. And the Type 3 grant provider is currently accessible for most other universities, but for these interactive or the DeiC Interactive resources, it is Type 1. If you click on that, you'll see that it opens up the rest of the application form. And if you have a look at the larger icons where you can see a link pops up every time I scroll over it, you'll see the 3 different providers that I mentioned previously. The first one is the SDU provider with the gray icon. The second one is this red Aalborg University icon, and that is for the virtual machines. You can see that they're titled that way as well in the product. And the third one down is this blue Aalborg University icon. And these are if you want to run apps at the Aalborg location. And you can see that the different types of resources have different names. Essentially, GC1 in the Aalborg component refers to general compute or CPUs. And in both the Aalborg and the SDU part, there is one called CEFS. And that CEFS is a network storage space. So basically everywhere where you see a CEFS product, that is where you need to apply for storage in that particular provider. You have to apply for storage in the Aalborg apps environment and in the SDU apps environment. And that is excluded from the virtual machine environment because the virtual machines come with built-in storage that is deleted when you stop your jobs in a virtual machine. So you don't have to actually apply for that in this middle section. For today's demo, the resources that we're going to demonstrate are CPU resources, so just standard CPU resources on the SDU platform where we could apply for, say, 500 core hours there. And we're going to run a GPU for example, 10 hours. And these GPUs that are called U3 GPU under the SDU component, these are the NVIDIA H100 GPUs. So these are the very large GPUs that can be used with sensitive data. And in this space, we have to apply for storage as well as our compute, because when you want to run an application on UCloud, you have to have storage available. And that's because when you run an app, you automatically also store all of the job information in your own storage, and that can't happen if you don't have some allocated storage. And we can apply for, say, 100 gigabytes of storage in this location. I'm applying for 100 gigabytes because I know I'm going to run the Chat UI app later, and that requires downloading relatively large models that are up to 40 or 50 gigabytes in size. So I know I'm going to need at least 100 gigabytes to run that demo later. I'm not going to be running any virtual machines. That's outside the scope of this demo, but I will be running some of the same applications. So I can run the Transcriber application and I can run the Chat UI application in the Aalborg apps environment. And to do that, I would need to get some CPU resources if I want to run CPU resources at Aalborg. And those are the UC1, GC1 or general compute CPU hours. And then all the others that you can see, the L4, the L40 and A10 are different types of GPU. They're all NVIDIA GPUs. And we also need to apply for storage. But for each of these GPUs, we could just apply for, in this demo, 10 hours of each. And we could also request 100 gigabytes of space in the Aalborg apps environment, just to make sure that we can also run that Chat UI app and pull those big models down and store them without having a space issue. So this is how you complete an application form with the resources. The different universities have different requirements and different options when it comes to the application section down here. You can see that for Aalborg University users, we don't require that they fill in the introduction, but for most other universities, I believe that this is where you provide information about what your research is. And we need to justify giving you these resources from DeiC. So it's a good idea to explain what you're doing, what is your research, what is it about, and why do you need these compute resources. That'll give the application processing person a good idea of why they should approve your application. We also request a DeiC project number, but some of the other universities do this in a different way. Once you've got all of your information inputted and you've provided a nice title for demo of Transcriber, if I can spell, in 2024 winter, then I can submit the application, and that application will be sent through to the people responsible for processing your applications at Aalborg University. That's Claudia, or essentially is the DeiC front office responsible for the applications of your university. Once that application has been sent off, the person processing it will either have comments for you or review it and check whether or not what you've provided makes sense. But when it's approved, you'll notice that it pops up in this drop-down section. You should also get a notification in email and a pop-up notification in this space. Now, that's the only one I've got started at the moment. If I switch over to that project, you'll notice that the resources that I applied for are now visible in this resource allocations section. For those of you who've got a new project, this recent runs section will be blank, and I'll show you where that comes from once we start running some applications. You may now be thinking, that's well and great, I can send off these applications, but what does it cost? And the good news is that it is entirely free for you as a researcher. Each of the universities has what is called a local resource allocation, and those local resources have a cap. At Aalborg University, I believe we have around 4 million CPU hours on the SDU part alone. So just to give you an idea of the scale, that goes up and down a little depending on which university you're coming from. In terms of GPU hours, it's in the range of 2,000 to around 20 or 30,000 for some of the different GPU types, depending on how many GPUs are available in the platform and how many GPU hours are allocated to each university. But again, consult your front office, get in touch with them via that DeiC Interactive HPC page. That's this interactivehpc.dk page. Get in touch with your front office and check what size project is reasonable for you to apply for. Beyond that, let's get into a little bit about what is available for people who want to do AI. As a general introduction, there are some pre-built tools, and the pre-built tools are available. If you have a look on the left-hand side, you'll find this little shopping bag icon, and that, if you hadn't guessed it already, takes you to a store or an app store, and there's a title called Store where you can click on that, and that'll take you to the App Store. And there you can browse through the applications, you can have a look at what's available in the different categories, and you can also just search for the app that you're looking for at the top of the screen. You can see that I've been using Transcriber and Chat UI, and if I go into that application at the top, you'll see that there's a star alongside the title. If I uncheck that star and browse across to the left-hand side, you'll see that I've now removed it from my starred applications. So it's just a way to make sure that you can quickly access the applications that you use on a regular basis. You can essentially favorite whichever apps you really want to use. The applications that I think are most relevant right now to highlight in terms of AI for those who are just getting started with this are going to be the ones we're presenting today. The Transcriber application is an AI transcription tool, and the Chat UI tool is essentially a chat support tool for large language models, where you can load in a predefined model and then run a chat on the basis of that model. The other tools that are relevant for AI are, of course, anything to do with running, for example, PyTorch or Python with any of the major AI engines in the back end. And those tools, I think, are best to get an overview of by browsing across down to the avatar in the bottom left corner of your screen and clicking on the UCloud Docs icon. The reason I'm suggesting this is because you can get access to an apps index, and that apps index will give you a good idea of what apps have been predefined and pre-built and are ready to run. You can see that there's also a text generation app. That's not one of the ones we'll be demoing today, but the majority of development tools are here too. You can access Python, you can access Jupyter Lab, you can run Coda with a Python or CUDA or a number of other backends. You can see by clicking on it what kind of backends you can use as a development interface. If anyone's wondering what Coda is, it is also known as Visual Code Studio. So it's just a development environment for those who often work with these things. The other main thing that I'd like to highlight here is that you can use a development environment like this for running the training of, say, an AI model, but you can also build far more complex multi-tool or multi-service solutions using some of the more complex Nginx integration pattern. Tomorrow's presentation is going to be on Nemo and on Triton, so you can also have a look at some of the Triton hands-on tutorials for those who are in the more advanced cases. The other major one that people often use or often want to know about on here is the setup of Conda and Conda environments, because you can have, in the user interface, set up your own drives and store your own environments and so on. But this is getting into far more complicated things and more advanced users. So I'm going to step back away from the details and take you back to the interface. The last thing just to mention here is that UCloud, yes, it does give you the option of scaling up the compute that you want, but it also gives you the option of scaling down. So it's not only applicable for people who want to run these tools using massive compute resources, it is also possible to run very small computers, or at least very small compute instances. So if I go to view details in the providers and just go into this SDU DeiC Interactive provider, you can see the different types of machines that are available today. We've had a basic introduction to UCloud and a quick introduction to what some of the resources are. The next stage of the presentation is the demos of the two applications, Transcriber and Chat UI, and then Federico will take over for a demo of Label Studio application. First of all, Transcriber is an automatic transcription application that runs on any audio that you upload to the platform and input into the app that's available. You just need to check whether or not your university has that data processing agreement in place. Check the classification of your research. If it's public and low risk internal data, you can use it on either of the first two options, the AAU options. If not, then you need to be on SDU. Estimate your processing time needs. For transcriptions, using a 16-core machine, we estimate that it's roughly 1-to-1 using that 16-core machine. So if you need 1 hour of audio to be transcribed, you'll need 16 cores for 1 hour. So it's a ratio of 1-to-16. If you have a GPU setup, depending on whether or not you've got access to an SDU GPU via a project, then you could potentially get access to this. It takes about 1/8 of the time to transcribe, but we always recommend 1/4 of the time in GPU hours, just in case you need to rerun it on a different setting. So for GPU hours, roughly 1/4 of your audio, you can estimate GPU hours to. And then either one of those options, depending on your rules at your university, might or might not need to end up in a project. You can only get additional GPU hours if you apply for additional resources. You then need to create a folder on the platform, upload your data to that folder. Prior to uploading your data, you should mark the folder as private, confidential, or sensitive, depending on your workflow and depending on whether or not you're in a project and collaborating with others. We always recommend that if you are going to upload any private or confidential or sensitive data to the platform, that you do mark that folder in advance of uploading any files. That makes sure that as you upload files, they inherit the properties of the folder. Then you should run the Transcriber application and inspect your output before downloading it. And we'll go through each of these steps as quickly as possible in the next part of this tutorial. Back to the UCloud interface, and we're going to assume that we're running a project where we have got sensitive data that we need to transcribe. So we're going to go into our file browser section, open drives, and just go into my member files section. In this member files section, you'll see when you first arrive here, it'll be blank, but I've deleted something, so the trash folder is there. I'm going to create a new folder and call this audio files. In that folder, I'm going to modify the sensitivity for that folder from private to sensitive, and I need to provide a reason. This is sensitive audio data, and say update. That now has changed the notation on the side of that folder to the red S. Now, going into that folder, I can shortly afterwards click the Upload Files button, where you're allowed to drag and drop files or folders into this location, and I'll just drag and drop these files into my folder for sensitive data. And you'll notice that the files, as they get uploaded, automatically inherit the nature of the folder that they get loaded into. The next step is to go back out to your landing page, or at least go across to the left-hand side to the navigation bar, where you can find this little shopping bag and click on the Store button at the top as an App Store. We'll search for Transcriber, and you'll find Transcriber is the top search option, and we enter the app parameters or inputs page. Let's give this a name, demo. Let's call it Transcriber audio transcription demo file 1. And I'm going to run each of these files independently. So if we choose a machine type here, you'll notice that all of the machines that I've been permitted to use are visible. But because I have stored that data in the SDU file section, I need to find a machine that runs on SDU's resources. And initially, we'll just choose the U1 standard provider, or at least product within the SDU provider, is a CPU only machine with 16 cores. And that is the machine that we've found is the most effective for doing transcriptions. We'll leave that as the machine type, and then further on down under the optional parameters, you need to either choose an input file or an input directory. One of those two options is required for this app to run successfully. You cannot choose both options. If you do that, the job will be provided with a flag for both the input file and the input directory and have an error. In this case, we're just going to run the input file, and we're going to select the input file parameter option. It pops up to the top, and then inside this gray box, you click in the blank space, and it allows you to come out and select the file that you want to input into the model. In the drop-down box on the left-hand side, you can see this little arrow, drop-down arrow, takes you into a space where you can select the drive that you want. And I want my SDU drive for my member files folder, and in that folder I have, or at least in that drive, I have a folder called audio, and then you can see I have Transcriber audio number 1 is file number 1, and I'll use that one. And then it just puts this path to the file into that additional parameters section. I also know that this is an English transcription. You can specify the language to be whichever language you want the output to be, and I'll just choose English, so you can see how an additional parameter can be input. Once that's set up, I can just click submit, and UCloud will then begin allocating compute resources to this job. I don't have to stay on this screen. If I want to, I can, and when it's done, I'll get an output screen. But instead of staying on the screen, I can browse back to my home screen and start another job for the second audio file. So if I go into the store again and click the store button and search for Transcriber, you'll see it is the top search option again. And if I don't want to have to search for this app every time I want to run it, I can click in the star next to the app name and it will be added across into my starred applications list under the applications inside this little shopping bag. That'll just make it easier to get to. If I want to run an identical job to the last one, I can click import parameters and just import the parameters from that previous transcription that I ran, and it chooses the machine type, but it also specifies the file. I don't want to use the same file, I want to use a different file, so I can just click that file input field, go into audio files and choose the second file and use that one. Click the use button and you'll see that it has updated the path to the second file. All the other fields are the same, and I can change the name of this to demo file 2 and click submit. If I go back to my home screen now, you'll see that on the right hand side under the recent runs panel, or at least in this tab on the right hand side, you can see that one job is currently running, that is the green one, and one is preparing to run. If I go into this one that has the green clock, you'll see that it is busy performing a transcription in this location, or at least in this job. It says it is busy running. But I can go back to my home screen and I can start the third file as well. UCloud is not restricted in terms of how many jobs you run simultaneously, except up to the point where all of the compute resources in the entire platform are used, and I haven't experienced that yet. But I can import the parameters for job number 2, change that job name to demo file 3, and select the correct input file here in the additional parameters, and just use that third file. And then I can check that all of the settings are correct, still using a vCPU machine, and click submit. While that is running, I'm just going to browse back to my home screen and show you what this recent run section looks like while those jobs are running. This transcription should take a total of around 3 minutes for all of these files to complete on a 1-to-1 scale once the transcriptions are running. You can see the first one is still running, and I've just had an update that the third one is underway. I can refresh my screen and it should show that all 3 are in that green clock state, which means they are currently running. I'm going to go across to files in my drives and go into my members files folder, where you will now see that a folder called jobs has been created. Inside jobs, you'll see there's a transcriber folder. Everything in this transcriber folder, if I'm using sensitive audio data, should also be marked as sensitive. So I can click across on the right hand side and change this sensitivity level to sensitive and say all transcription outputs are also sensitive in nature, and update that. And then I can go back to my landing page to see how far my transcriptions are. If I click on demo file 1, I can go in and see how this is progressing. It doesn't tell me what percentage of the file is transcribed, but you can see that the transcription is currently running. Now that I've got a notification that at least one of my jobs is completed, and you can see demo file 3 has completed its transcription. That was the smallest of the 3 files, and that makes sense. So I can go now into that previous job just by clicking in this recent run section on that job's name. And you see the job started and terminated, and you can see there's now an output folder in this directory that is displayed at the bottom of the screen. You can also see that all of the outputs in this folder have been marked sensitive, because the outputs of a job that run in the default location all end up in the jobs folder, and the jobs folder has the transcriber folder, which I marked as sensitive. If I open that, you'll see that each of the jobs that I'm running has its own folder in this location, and they've inherited that sensitive nature. I can also open that file location by going into this demo transcription file 3 folder, and all the same outputs are there. The actual outputs of the transcription are in this out folder, and you can see the files located in that directory. So you can browse to those files via 2 routes. One is browsing via the recent runs screen, where you can see when a file has completed its transcription. The other is going via your file browser and going into the files in this location here via jobs. We could take this entire transcriber folder and copy it over, or we could share it with a colleague in our project. audio files have been transcribed, and I can browse into those jobs by just clicking here again in the recent runs section. If I go into one of the outputs, for example, this audio file 2, I can inspect the audio output, or at least the text output, by just double clicking on the file that is titled .txt. In here, you can see the text of this discussion that I had with a colleague. If I go back, you can see all three of those folders again. Go into the first one, and if you want to download this data in order to be able to work on it on your local machine, the model, or at least the app, is set up so that in your out folder or in the output directory, there is a zip file included in the output. And that file can be downloaded as an individual file. One thing to be aware of when exporting this data to your local machine is that editing one file will of course not update the contents of any of the others. And that is something we're working on for a future iteration of the outputs of this app. But that's it for transcription, and I hope you get something out of it. Just something to note is that when you do run this application, there is an option for changing. Let me just open the application up and click run, or at least one of the recent runs, and run again. Down in the app options, there's an option for selecting the type of model. It does sometimes happen that the output improves by modifying the model. Medium occasionally gives better timestamps in subtitles file, but you need to test this with your data and see which of the models gives you the best output, which is part of the reason why we recommend allocating slightly more resources, or roughly double the resources you need when running transcriptions of the Chat UI app. Chat UI is essentially a chat hosting application that allows you to import any of a number of pre-built and predefined LLM or large language models with which you can interact in a safe, or at least a secure, environment once you have created your own server. To set Chat UI up, it's roughly the same steps as for Transcriber. You need to know what kind of data you're working with. If you're working with sensitive data of any kind, you need to be on the SDU provider. And in this case, when you estimate the amount of time you need, you're going to be working with an inference device. So in this case, you're running a chatbot in the background, and then the model you're running in the background needs to be accessible while you need it, in which case you need to understand how long you want to have access to this chat environment. As you can see, there are 4 different kinds of GPUs available. The A10s, L4s, and L40s, which you can see in this line around here. The first 3 kinds of GPUs are only available in the AAUK8 provider, which means that these GPUs are only available for non-sensitive data applications or public or low-risk internal data. The H100 GPU, which has 80 gigabytes of onboard memory per card, is hosted at SDU, which means you can use sensitive data for those applications. To get access to GPU resources, you need to either apply for a project or apply for additional resources on top of your personal allocation. At Aalborg University, for example, this must be in a project. You then need to create your data folder for the application, run the Chat UI app, and then sign up as an admin user. But that's it for the introduction, and let's get set up. A project setup where you have these GPU hours available. You'll see them in your resource allocations on the left-hand side. You can expand this to see all of your resource allocations from a compute point of view and a storage point of view. But going back to our landing page, we'll get ready now to set up this Chat UI application. Initially, what you could do is go to your drives, go to your members files, and set up a storage location. But I'll do this setup now from inside the application, which is, in my opinion, a slightly more streamlined way to access it. You can access it via the store icon, at least the shopping bag icon, and the app store. Search for Chat UI. And again, when I open the Chat UI app, I'm going to just star it straight away so that I can get it immediately in my start applications. And then give this Chat UI demo job a name. No special characters in these job names. And I'm going to choose an Aalborg Kubernetes GPU. So I'm going to run this in an Aalborg storage location. And when I do this, I need to specify a data volume in the Aalborg member files folder. And you can see it automatically directs me to this Aalborg location and does not let me select the SDU files. So I'm going to create a folder in here called Chat UI App Data folder and hit enter, select the app or select the folder, and then just use this folder. And that is now my directory. And you can see that I can go down the bottom here and set up a public link, for example, if I want this to be accessible via a browser. But this demonstration is going to just be a short and sweet demonstration of how to use the application for the first time. When you start this application up, if I click submit, you'll see that it starts to allocate the compute resources. Once it's found a machine for me, it will start the application setup. This application setup, for the very first time you run it, takes around 10 to 12 minutes. So don't be surprised if nothing appears to be happening once the application starts up. I'm going to go back out to my home screen and I'm going to set up another instance of this Chat UI running on the SDU compute via an H100 GPU. So let's go to the store, Chat UI, and let's just import the parameters from the previous job. And I'm going to change this name to SDU, and I'm going to change the machine type to the SDU, so SDU's U3 GPU, that's the H100 GPUs, and I'm going to pick one of those. It's not going to help me to allocate across multiple GPUs, but I'm going to run this big GPU so that we can show you how to allocate one of the biggest models. So, for example, a 70 billion parameter llama model will be the example we use. In this case, the Chat UI app folder that we had previously allocated is no longer accessible. So we need to change that. And you'll see if I go to my member files here, that folder doesn't exist. So let's create a new folder in our SDU storage location called Chat UI App Data folder. And I'll just give it SDU as a name just to make sure that we can see that it's an SDU folder. And now the use button's over on the right hand side. And I'll click use on that folder. And now this app is ready to run for the demo on the SDU location. And let's just submit that. If I go back to my home screen now, you'll see in the recent runs that I have 2 Chat UI demo windows running. I'm not going to record the full 10 minutes it takes to set these up, but once those are set up, we'll go into the application by double clicking on it. And then once the job is started, I'll get the option of opening a terminal and opening an interface up on the right hand side. Okay, so now both of my Chat UI instances are running. I'll open the Aalborg version, or the Aalborg one, and just check that everything is operational. It is. You can see that in the node 1 information on the left hand side here. The Ollama backend has loaded, the embedding model is loaded, speech to text model is loaded. Perfect. And then you can see after the web UI is served up, you'll see that UVcorn is running on, and you get a port number. And up at the top of the screen now, I can click on Open Interface, and I'll be taken across to the Chat UI interface. And remember, the Aalborg instance is running on an A10. So I'm going to sign up. So at the bottom, I had to switch over to sign up. Let's call it Rob Smith and give it an email. And give it a password and create the account. And when I do that, it will create a admin account or an admin account, and I'll have access to the interface. Initially, there are no models, and if I try to run anything, nothing will actually happen. So I need to click up on the right hand side where you can see the account or avatar, click settings, and then in the admin settings, you can see I can go in and remove the option to to enable new signups, or at least disable new signups, and save that setting. Now that should be saved, and I can go across to models on the left hand side, and from here I can now choose what model it is that I want to run my chat instance on. So if I read underneath this, pull a model from olama.com to access available model names for downloading, click here. It opens up a new tab in my browser, and you can see the names of all the models that are available. If I go into Llama 3, which is one of the more capable, and I just copy the name over there, Llama 3, LLAMA3, and go back to my admin panel, I can paste that name in for the model that I want to browse or to download. You can also specify, you can see in here that there are two options for this model, an 8 billion and a 70 billion parameter model. And I'm going to go back to my admin panel, type colon and 8B for the 8 billion parameter model, and click the download button on the right hand side here. After which it's going to pull a manifest and load that model into my chat environment. Once that model is loaded, I will go back to the left hand side in the dashboard and start a chat. But I'm going to give it a chance to fully load this model. While it's doing that, there we go, it has loaded. All right, perfect. I'm going to go across to the left hand side on those three dashed lines over there and start a new chat. And now at the top left hand side, I can use the drop down to select the Llama 3 8 billion parameter model. And at this point, I can now start asking it questions. Hi, Llama 3, do you know who the president of the United States was in 1968? And ask. And then it will process it. The initial prompt might take some time, but you can see that was relatively quick, and it has given some kind of answer. It just says, hi there, for now. And I'll edit this and send it again and see whether or not it completes the answer. It does. So you can see it just gave me an hello there to start with, but now it's given me a more complete answer and tells me that it was President Johnson in 1968, at least at the start of the year. Okay, that is getting the model set up and starting to run on 8 billion parameters, just a standard model. In addition to that, you can do what is called a RAG. To get into that, I am going to go across to UCloud, go back to my home screen, and go into my SDU model so that I can allow this to start loading the larger model while we go about the RAG, or the Retrieval Augmented Generation. So basically, we go back into the running application and click Open Interface. And while that is opening up, I'll need to sign up because this is running at SDU. It's a totally new app that is running down there, and I need to then provide it with my information. And create that admin account. And the first thing I'm going to go and do is go into my admin panel, settings, and admin settings, and disable new signups, and click save down at the bottom. And settings have been saved successfully. All right, going to the models tab in the navigation bar, and in this case I'm going to type Llama 3 and get the 70 billion parameter model and download that one. So I'm now running on the SDU side on the very big H100 GPU. This is a much bigger model to download, and it takes a lot longer to load it into memory and requires a much bigger GPU. So that's why I'm using the SDU's H100 GPU for that. Let's go back across to the Aalborg University one. RAG, which I mentioned before, is Retrieval Augmented Generation, or in layman's terms, it means you can provide additional information that you want to use as a special addition to the training material that the model was based on. And to do that, you can just click the plus button next to the send message section and click upload files.
And one of the things I have downloaded is the learning material for the Indfødsretspro in Denmark. And if you are new to Denmark, the Indfødsretspro is a test that people who have applied for Danish citizenship must pass in order to be approved for Danish citizenship, or at least in order to apply in the first place. And that is completed, or at least it's made public once a year. And you can log into TV2's website to go in and see whether or not you could have passed the Indfødsretspro yourself. And we'll use Chat UI in a second to see how accurately it can answer the questions in the Indfødsretspro for 2024. Large model is now loaded in my SDU panel. So let's go start a new chat there. And you will see in the drop-down box, I have the 70 billion parameters model here. And here I'm also going to load in that Indfødsretspro reading material. And let's upload that. It takes some time to do this, and we'll be right back as soon as that is done. The chat input field at the bottom of the screen, the reading material for the Indfødsretspro has finished loading, in which case I'm going to open up a new tab for TV2 Indfødsretspro and browse to that website. And you can see the questions that came up for the 2024 test are here. Now that we've added that material to our chat, we can just take one of these questions, which says how many or what percentage of votes must a party have in order to be represented in the Danish Parliament. Go in across to this chat and ask our reading material how many it needs to be according to the context. You need to receive roughly 2%. Let's have a look at the answers. And there's a minimum of 2%. That was correct. We also then can ask which party was Inger Støjberg a part of previously. And she's obviously become part of the reading material, and it says she was part of Venstre. And we can see, was Venstre a part of those answers? It was indeed, and was correct. And let's do that for the next one. When did the moderate party, or Moderaterne, become a part of the election campaigns? 2022. Is that one of the options? It is indeed. And let's have a look at how this goes at the end of this. I've noticed that I'm approaching roughly 1 hour of running these jobs. And if you remember, when I started these jobs, I only set them to run for 1 hour. So you can see the time remaining for this job is only 5 minutes. If I'd like to add time, I can just click this plus 1 hour button, and you'll see the time remaining on my job has been extended. I'll need to go and do that for both apps. Let me just check the AAU K8 one, whether that's still only got 5 minutes. Let's add an hour to that just to be sure that it keeps running while I'm recording. Providing all of the questions to our model with the Indfødsretspro's reading material provided, I managed to get 39 out of 40 correct. And in the last part of the questionnaires, I had to guess the last 5 because these current affairs or current events questions were not part of the material, but just some guessing got me through those last few. And then finally, in the ethical questions, ironically, one of the questions that I provided came back incorrect. So a comfortable pass on Indfødsretspro.
Another option when using the Chat UI interface is to generate images using an AI engine. And we can again open the Chat UI interface by opening the app, create a job, and we can just use some previous parameters for a job, import those parameters, and then we can pick the machine that we want to run it on. I will just pick an alternate. We'll run it on the UCloud GPUs. And the primary data folder is selected. Let's just make sure that we are in our UCloud data folder or the SDU provider. And then down in the optional parameters, you need to search for enable image generation, or at least text to image generation. And if you set that to true, you can simply click run or submit on the job. And you will relaunch your Chat UI interface that you had previously shut down. The front end is now up and running, and we can open the interface. We just need to log into the interface.
And hopefully we should be able to spin up the model that we had previously loaded. The default model is the arena model, but we can spin up the llama 70 billion model and ask it to generate an image for us. Please generate an image of a greenhouse next to a picturesque lake, if I can spell. The initial response will be text once the model is loaded into memory, but it might take a minute for that to be implemented. I'm happy to help, however, the text-based AI model doesn't have the capability to do that. In order to generate an image, we just need to provide a prompt that creates a response from the model that describes the image we want. So we'll change this to, please repeat exactly the following. Now we have a string of text, and with that string of text there is an image just below the text that we can click on, and it will generate a greenhouse for us just alongside a picturesque lake. Of course, it's not perfect, and if we want to try to resubmit that, we can edit that and save and click the generate image button again. And of course, a greenhouse can be interpreted as many things, and in this case they are assuming, or at least the model is assuming, that we want some kind of house for growing plants in it. But that's how difficult it is to start generating images. The quality of the images depends on your prompts, but that is as complicated as it gets. The last thing to demonstrate in this chat UI or this chat UI app is the summarization of documents. And in order to do that, we just need to have a document available that we want to summarize, or at least to get the gist out of. And in my downloads folder, I have stored the letter from Bill Gates to what he called hobbyists. And if I just click the add button and upload files, I can upload the Bill Gates letter. And once that is uploaded, I can then ask the model to provide me with a summary. Please summarize this letter. And that will simply provide me with a summary. You could also ask for alternate things. You could ask it to please rephrase this letter in the tone of Winston Churchill. And then it will do its best to use its own understanding of Winston Churchill's capabilities, or his own language or tone and prose, that to generate a new text communicating the same message as it understands it from that letter. Something always to bear in mind with these models is that each letter and each word that comes out of the model is essentially just a probabilistic expectation of the model. So it is not information based, it is purely statistically based. And these models always have the possibility of hallucinating and providing absolute garbage coming out of it. But in this case, it seems to be relatively accurate. My dear fellow hobbyists, we stand at the precipice of a great crisis, etc., etc. And we hope you get the best out of ChatUI and the Transcriber application. And please feel free to get in touch with your front office in case you need any support for how to get onto the platform, how to use the applications, or how you can get additional resources for running them.
I'm going to talk about Label Studio, as Robert introduced before. This is a tool in general which allows to label different kind of data, which can be images, videos, audio, and so on, and also integrate with machine learning pipelines. So in principle, one can use in an advanced way and essentially run a machine learning model for which one can have machine learning assisted labeling, for example, and interactive annotation and so on. So we implement the application on UCloud, and here I'm showing the documentation, which essentially explain a bit which kind of parameter you need to use while running the application. So if I now go on the page, so Robert explained a lot about how to go on the App Store and select the application. So I will not repeat this, but once you select Label Studio, you have, as in the case of Transcriber or ChatUI, you have to fill some field. And except the other, the common one, which are job name and machine type, there are other parameters which are more specific to the application. So I want to mention that in this particular case, you don't need the GPU. And of course, depends which kind of image or videos you want to use and annotate, but essentially 2-4 CPU cores are okay, essentially. And then you have to specify at least a data directory, which can be empty the first time and will contain the app data, and in particular the database, which will contain all the information, including the login information, and also if you decide to add collaborators, the model you use, and so on. So when you start the application, now I can use an application which already started, so it's faster. In this case, maybe first I can show to you which kind of parameter I choose, which are this one. So I decide to select 2 folders, because in this way I'm not only able to upload file from my computer, but also to create some cloud storage, which take the data from UCloud. In my case, actually I could use also this folder, but this folder contains the audio files, some audio files, and this folder contains some transcriptions, but in this case, in the first example, are not so necessary. And then this is the data directory. I decided already to put the information about login. So I just choose the email, which should be the username, and just the password, which I will delete now. Yeah, so when I start the job, I will see something like this. So I have the opportunity to open the terminal and then to see, for example, the folder I decided to mount with the application and the data directory I mentioned to you. And then I can open the interface. In this particular case, I already create a project, but it's very easy to do a new project by clicking on the button on the right. And then I can enter in the project. And in this specific case, if I go in the setting, we can see that I already added some storage. So I ask to the app to point to the folder I mounted, so that to be able to see some audio files. So as I said, it could be done with essentially images. You can annotate images, you can annotate the audio file and the text and so on. I choose audio file because I'm using exactly the file which were produced by Robert from Transcriber. Robert used with the Transcriber. So these are essentially only the audio file. And for each of these, it is possible when you, as a basic usage, you can, in the setting, also decide which kind of labeling setup you want to have. There are a lot of templates which are made from for different usage, so videos and so on. There are a lot here. And you really can cut and paste the code in the application. What I decide is very simple. So I have essentially I show the audio which can be listened. And this is an audio which were registered by Robert. And then for each segment, one can select the segment, for example, and listen the segment and decide to which one of these label want to use. This is a specific case in which the label is just to try to recognize if it's a question, if the answer satisfied the user and so on. And for each of these, I can update and save, and then I can export essentially in my computer the file with the new annotation. Now, following a bit the workflow which Robert presented, we thought we were inspired by a use case, and we decided to build an app which is essentially a speech analyzer, which is based on Label Studio, but has already a lot of settings included which automatize all the procedure I show to you. So choose a model and choose some setting from the cloud storage, and is able to create some task and so on. So what we want to do is to essentially run Label Studio. And in this particular case, what we did is to use a different set of parameters, a bit more elaborated. So I can show to you, should be this one, I think. So here, what I do is I essentially need the transcript folder which contain the transcription which are produced from Transcriber. Then I mount also the audio file, which are the original audio file which were used for the transcriptions. And then I decide to have an edited file in which essentially I would like to put the transcription which I edited because they were not totally correct. So the idea of this setup is to listen the audio and to look at the transcription which were done automatically by Transcriber and correct and editing all the transcription. And so we use a script, as I said, to automatize some procedure, and this will be integrated in the new app which will be developed very soon on UCloud, which will be called Speech Analyzer. And in this case, if we go now on the application, for example, I open the interface, I have already my project, which I created. And as I see, I have different tasks, which correspond once again to the different audio file which Robert provided. Now, if I click here, what I can see is that I choose a different labeling model for the annotation. And in this case, I can select the fragment, listen the fragment, and then be pointed to the right part of the transcription and decide to change the transcription because, for example, some word is not correct or is I don't know, the speaker is not correct. There are something in the transcription which is not okay. So once I selected the segment, I can make my transcription here. And when I updated, I can see already in the edited directory that I have the new file with all the correction. For example, to speed up a bit, I make some correction here. And if we go now on the right directory, which is edited, then I see that I have all my transcription, and in particular, this was the 21. And if I look, because the SRT file essentially is a text file, so I can see that there are all the correction I made. So essentially, when I update from the application, I have still my directory with the audio file, my directory with the transcription, but I have also a new directory in which I improved the transcription and I edited my corrections. So as I said, this requires to set some labeling setup for the annotation and so on. And we will implement an app. I think probably end of the year or beginning of the new year, in which this all will be automatized. So the user will start, we will have to decide which folder to use, have the data essentially, and will be able to speech and listen and analyze the transcription. So there are a lot of documentation about the software for all the steps, and even for introducing machine learning pipelines into it. And there are a lot of documentation on UCloud that you can find exactly as Robert pointed out. So, and which will guide you essentially in all the steps. Yeah, so more or less, I think this is all what I want to say on Label Studio. Welcome.
I think that's going to have to wrap it up for today. We've just gone over 2 o'clock. I just want to thank everybody who's participated and come and watch the presentation for today. And I hope you guys got something out of it. If you have any suggestions or requests for additional presentations, we'd love to hear about them. We have got some very good data scientists that have a lot of experience with these applications, and we could do more in-depth or more detailed presentations of ones that you'd like to see. Thanks again, everybody, and thank you so much to Federica. That was an amazing presentation, and I can't wait for Label Studio to come online. I think it's going to be awesome when it's...
Label Studio is
there. I mean, Speech Analyzer is the right name.
Perfect. Okay.
To come online.
Thank you too.
Otherwise, have a great afternoon, everyone, and that's us signing out. Cheers for now.
Bye-bye. Bye.